We are looking at the data section of the Prac exam, and we're going to look at the solutions, and we're going to go through it with a bit of cheer and have some fun. So we have the first part is a stem and leaf plot, and these are the results of a maths test that are represented by the stem and leaf plot, and from that we have to find the mean, the median and the mode. So when doing that, we have to recognize that the stem is the same as the tens. Okay, they're the tens and they're the units, so we read it as 57 and 58 and 58%. Okay, so we can find the mean by adding up all the values to get a total. Alright, we've got 25 data values there. So the mean is add them all up to get a total, and then you must divide by 25 the amount we have. And do that in the calculator, we'll get that value, 71.32. That's your mean. Now the median is your middle number. So we will find that the median is this data value there, 71. And what you have to do is make sure that all the other data values to the left of this one is the same amount as the number of data values to the right of it. And we will have 12 on either side. So 71 is the middle number, and that is your median. And then the mode is the most common data value, and you can see it there here where the data value 63 occurs 3 times, and that's the most commonly occurring data value. So the mode is 63. Okay, so mean, median and mode from a stem and leaf plot. Okay, now using the midpoint of class intervals, that's these values here, calculate the mean of a basketball team's final score for the year, represented in the following frequency table. So here are all the scores that the basketball team achieved in groups. So in the group, for instance, 1 to 20, scores 1 to 20, there are 10 results in that group. In the group 21 to 40, there are 12 amounts of data points. Okay, in the group 41 to 60, there are 9 data points. Okay, and we use the midpoint value as a number to represent the group. Okay, so the first thing we have to do to get the mean is think about what we did before in the previous example. We have to add up all the data values to get a total. So what we're doing here is obtaining a total by taking the frequency number, the amount of data values, of 10. Okay, and the midpoint is the number we're going to use to represent the group from 1 to 20. Alright, so we've got 4 lots of 10, and the next total for the group 21 to 40, we've got 12 lots of 30, and so on. And so we keep working at each total, the total of the data values for each group, by taking the midpoint multiplied by the frequency, and then to get a grand total of all the data values altogether, okay, we're going to add this column here. And it's also important to note how many data values we have. Well, the frequency or amount is the number of data values we have in each group. So if we add these up to get a total, it gives you the total amount of data values we have altogether. So the grand total we have here is the sum of all the values, and then the mean, the average value, is we take this grand total and then we're going to divide by the frequency total, this a number, and that will give you a mean of, there it is, there's our division we have to do, and we get a mean of 37.9. So on average in this group here, 21 to 40, which is also the most common, that's where the mean will lie, 37.9. Okay. Alright, next question. The following data represents the scores of a soccer team. So there's the number of goals of the soccer team. Now from that we have to create a 5-number summary of the data. So what are the main types of numbers that are in the 5-number summary? We've got the minimum, the lower quartile, the median, the upper quartile, and the maximum data value. Okay, now by observing the data we can work out what before we start thinking about any of it, we're going to first rearrange, make sure it's in an order from smallest up to largest. So you go through and you write it again out in order, and as you write out the data value in order you cross out the ones that you've used in the original set. And from that we can see what the minimum is, that is 1. Okay, and you can also straight away, you know what the maximum is. You've got a 9. And then here I'm thinking about the median now. Here is about the middle point of the data, and I know it's the middle because I've got 1, 2, 3, 4, 5 on the left and 1, 2, 3, 4, 5 on the right, so it must be right in the middle there. We have to think, well, what is the value between 4 and 6? Well, I can work it out by adding the values together and then dividing by 2, and I will get a median of 5. And then if I look at the first half, this bit here, then the median, the middle number of the first half is 3, so we call that the lower quartile. And then the middle number of the second half is 7, we call that the upper quartile. And there we have it, our 5-number summary. Okay, part B, we have to find the range and the interquartile range for the data. Well, the interquartile range is Q3 minus Q1. Okay, so that is this number here, your upper quartile, 7, and you're subtracting 3, and that gives you a value of 4. Now your range would be the maximum number, 9, subtract the minimum number, 8. So in this example the range is a value of 9 take 1 is 8. Okay, so we're going to draw the box plot of this data, and the box plot comes from the 5-number summary. So there's the results we got for the 5-number summary of the data, and the first stuff we're going to draw is the middle box part. Okay, there it is. Now the box here starts at this value 3.0, because you've got a lower quarter of 3, and that goes right up to the upper quartile, 7.0. That's that number there. And then we put a line in the middle, that is our median of 5 right there. And then we put a whisker from the lower quartile down to the minimum, a minimum of 1. So that comes down to 1.0. And then we put another whisker from the upper quartile all the way up to the maximum, 9. And there's your box plot. Okay, easy, yeah? Alright. Now, this is a problem-solving question. So, reading the information carefully, we're going to try and figure out a list of 6 numbers, a set of data. So the mean and median of 6 1, 2, 3, 4, 5, 6, 2-digit. So each number has 2 digits. Prime numbers. So a prime number is a number that can only be divided by itself and the number 1. So that means a 2 can't go into it, or a 3 can't go into it, or a 4 can't go into it. Any other number can't divide into a prime number. Only it is divisible by itself and 1. Okay, such as 13. The only way you can get a 13 in multiplication is a 1 times 13. That's it. Okay. And so our mean and median are both 39. Okay. And the mode is 31. Now the mode means most common, so that tells me there's going to be more 31s than other numbers. And then the smallest number is a 13. So I can start there. The smallest number is a 13, so the 13 is going to be my first number in the set, going from smallest up to largest. So, using the information about the median and the mode, I know that the median is the middle number. So the middle number of this data set is right in the middle here. So this number here, right in the middle, has to be a 39. Now that means that the number before it and the number after it, they have to add and then divide by 2 to give us a 39. Okay, and because the mode is 31, a 31 is smaller than 39, so that means 31 is going to appear to the left here, and there's only 2 spots available. So I'm going to go and say that the mode, which is most common number, is going to 31 is going to occur twice, there and there. Okay. So for 39 to be a median, I've got a 31 to the left and some other number here which we don't know. I have to add some unknown number, and then when I divide by 2 I'm going to get my median of 39. And I've given myself a little equation to think about. 31 plus some number, then I divide by 2, gives me 39. What is that number? Well, how about if I undo this equation? How about if I multiply by 2? Okay. And after multiplying by 2, I'm going to, instead of add 31, I'm going to subtract 31. So this reverse problem here is equivalent to my unknown missing number in the square. And when I evaluate that, 78 take 31, that's going to give me a 47. And 47, lo and behold, is also a prime number. So that fits the description of what my numbers need to be. 47 is 2-digit and it's a prime number. So therefore, boom, there it is. I figured out another number. That must be a 47. Okay, did you get that? Now, let's use the last piece of information. It says that the mean, that is when you add up all the numbers, you plus them all together, and that is also going to give me a 39. So the mean, I add them all up, plus the 2 numbers that I don't know, that's this one and that one, and then I divide by how many I've got, 6, and that's going to give me a 39. So I've got myself another little equation that I'm going to work out. So instead of dividing by 6 here, let's undo that division and let's do the inverse. Let's multiply. Okay, so this part has a total of 122 plus my 2 unknown numbers, and then I've got 39 multiplied by 6 to give me 234. Now let's subtract 122 on both sides. So I've got 2 numbers adding together to have a sum of 112. Okay, now these two numbers, they could be any numbers, right? Well, not really, because those two numbers have to be 2 digits and they have to be prime numbers. So I have to think about what are other prime numbers larger than 47. What's the next prime number after 47? Well, it is going to be a 51. So if I try 51, then 51 plus another number, 61, well, that gives me 112. And I'm lucky because the number 61, well, that is also a prime number, and that fits in nicely with my description. So there we have it. I've figured out my 6 unknown numbers for 6 marks. So that's going to test your understanding of your meaning of mean, median, mode, and applying the rules for working out mean, median, mode in different ways. Make sure you have an understanding about prime numbers. So go and Google that now if you're unsure. Okay, so the next one here, we have a question about some data. Here we go. For a certain species of tree, the diameter of the trunk and the age of the tree are recorded in the following table. So this is bivariate data, where we've got data pairs of data of age in years and the diameter that the tree will be at that age in meters. Okay, so let's construct a scatter plot for the data obtained. Alright, let's do a scatter plot. First off, we have to do a scale. So I'm going to put on my horizontal axis at the bottom all my data for age. Now I have to do it as a scale, so starting from 0 and then going up by 2s, 2, 4, 6, 8, 10, 12, and that gives me a scale for age where I can put all my age data. Okay, and then I must set up a scale of numbers for diameter. So starting from 0 going up by 0.5s, I can now put my diameter data there. So putting them in pairs, I'm plotting points. And there we have it. So carefully using the grid, looking at the pairs. When age is 2, diameter is 0.5. So I line up when age is 2, diameter is 0.5, and there's a point right there, and so on. And I do that for each data pair to plot the point. Okay, now the next question asks describe the correlation between the variables. So my two variables are age in years and diameter in meters, and that's the scatter plot of the diameter of a tree and the age of the tree. Now the trend is it's going upwards trend, so that's a positive direction, and because all the points are very close together, almost on a perfectly straight line, we've got a strong correlation and linear for a straight line. Okay, that's describing the correlation right there. And then we have to draw a line of best fit on the graph. So just with a ruler, as best as we possibly can we line up a straight line that can get as close as possible to each of the points. Yep, and there's your line of best fit. Now for the next question, we have to choose 2 points that sit on the line. Alright, and the best way to do it is to see where the line the line of best fit crosses through main interval lines of our grid. Okay, so this one is for 4, the x equals 4, and the y coordinate is a 1. Okay, And to use those 2 points, it says identify 2 coordinates that fall on the line. Okay, I did that. I picked them as accurately as I can, reading it from the scale. And from that I have to determine the equation for the line. Okay, now the equation for the line is made up of 2 parts. I need my gradient and I need my y-intercept. So the gradient of the line is my m number. That is made up as the rise divide run. Now, from 2 coordinates, the rise is the same as the change in y values. So y2 minus y1. So I'm going to take that as the second y value, and this one here is the first y value. And the same effects. So let's label the points as x2, y2, and this one x1, y1. And I take the values and I substitute them into my little rule for gradient, rise over run. Carry out the subtractions and I do the division. And I get this number, 0.273. Now that's the steepness of the straight line. That's my gradient. So this is what I'm achieving, my equation of a straight line, y equals mx plus c. And I've now determined the m number. Let's work out the c number. This is the y-intercept. What we can do is just choose one of the points that sit on the straight line. Okay? So using the value for gradient, I'm going to use one of the points, x equals 3 and y equals 1. So I take those values and I substitute that into the rule for the straight line that I've got. Okay, so the y, I put a 1, and the x, I put a 4, and I do the little calculation and I solve for y. And there it is. C is equal to negative 0.094, because I've solved for c, this one here. Okay, and altogether, there's the equation of the straight line. Y equals mx plus c. There's my gradient times x minus the y-intercept that I've worked out. Okay. Now, I have to answer the following questions to analyze my bivariate data. What was the diameter of the oldest tree? Now, the oldest tree can be read straight from the table. So the oldest tree is the one with the biggest, the maximum age. So I go to my table of values and I look up maximum age, and the diameter corresponds with that maximum age is 4.7. Okay, it's just reading straight from the table. The next question, how old was the tree with the smallest diameter? So again, I go to the table of values on the previous page and I look up the minimum diameter value. And I record down the age. So what is the corresponding age value for the smallest diameter? And it was 2 years. Okay, now that is rather straightforward, so no one should have troubles with that. But the next part, use the equation found in part E, so that's this equation here. And we're going to estimate the number of years a tree will take to reach a diameter of 10 meters. So in your equation, that's it there, there's some important things to recognize. The y value of the equation, well, that represents the diameter. Okay, so for a diameter of 10 meters, we're going to use y equals 10. And when I put that into my equation, 10 is equal to 0.273 times x minus 0.094. I've got a little equation that I have to solve for x. So I can add 0.094 to 10 to get that number there, and then I divide by 0.273, and that gives me the age, the x value, which is the age of the tree. Okay, to the whole number, 37 years. Then the next question, it says estimate the diameter of a tree at the age of 0. So essentially what we're doing now is from the equation, x here, well, that just represents the age. So I use the value where age is 0. That means x is equal to 0. And from that, I'll have this calculation I have to do. 0.273 times 0 minus 0.094. And that just gives me this number, negative 0.094. And that is pretty approximately close to 0 meters, which makes sense. At a age of 0 years, as soon as the plant is born, it has 0 diameter. Okay? And we have finished our work on bivariate data. The next section we will look at is the measurement. That's in the next video. I hope that was helpful, and keep studying.